Let's talk about solving quadratic inequalities. Now, remember, the word quadratic means that we have a degree of 2. The first one that we'll try will be x squared plus 2x minus 15 greater than or equal to 0. Now, if this had been an equation, instead of having this inequality symbol, we would first put everything on one side with 0 on the other. Then we would factor it as much as we possibly can. Let's see if we can begin this problem in the same way. Notice that this one already has everything on one side with 0 on the other. So now all I've got to do is try to factor this stuff as much as I can. The way that it factors is as x plus 5 times x minus 3. Now, if this were an equation, we would set each of these factors individually equal to 0 and solve to get our solutions. We would find -5 as a solution for the first factor, and we would find 3 as a solution for the second factor. The first thing that you're going to notice different for our solving something that is a quadratic inequality, instead of saying solutions, let's call these critical values at -5 and 3. Then the next thing that you'll see, since it's an inequality, let's take those critical values and let's put them on a number line. -5 is to the left since it's smaller, and 3 is on the right. Now, this gives me 3 different sections of this number line that I want to look at to see if my inequality is true or not. I've got the stuff that is to the left of -5. I've got the things that are in the middle between -5 and 3. And then I've got the stuff out here to the right that is more than 3. Now, I want to pick a number from each of those sections to test in my inequality to see if it gives me a true statement or not. As I do my substituting, I'm going to choose to substitute in our factored form, which was x plus 5 times x minus 3 greater than or equal to 0. Any number that I pick in this left-hand section will work. Anything out here represents the entire section. To make the arithmetic easy and for me to more readily see what the signs of things are going to be, I'm going to pick -10 to represent the section out here. Now, the middle section, notice that 0 is part of this middle section. 0 is the best number you can ever do arithmetic with, so I'm going to choose to let 0 represent the middle section. Over here on the right-hand side, I just need to pick somebody that's more than 3. You can pick anybody that you want. I'm going to choose 10 so that the arithmetic is easy and so that the signs are easy for me to determine. So we'll take those numbers and substitute for x into this factored form. Let's see how that looks. Remember, for our left side, we chose to let x be -10. So everywhere there's an x, I'm going to put -10 in its place. For the first factor, that gives me -10 plus 5. -10 plus 5 is -5. Now, I don't care so much that it's -5 as much as I care that it is a negative number that we have there. Let's look at the second factor. -10 minus 3, while it's true that that is -13, what I really care about is that it is a negative number. Why I care about that is taking the negative that is here and the negative that is there, multiplying those things together. 2 negatives make a positive. 2 negatives making a positive means that it would be greater than 0. I don't actually have to multiply this out to see that it is going to be something true. Now, if you want to multiply those together and see that it's +65 greater than or equal to 0, that's fine. But the important thing to notice is negative times negative made positive, and a positive is greater than or equal to 0. So our left side gave us a true statement. Now, I've marked things that are going to work in green for us to keep track of this. The left side of the picture works. Let's try the middle section next. Remember, the middle section, we wanted to put 0 in for all of our x's. So when I put 0 in for x, it gives me 0 plus 5 for the first factor, and it gives me 0 minus 3 for the second factor. 0 plus 5 is positive 5. 0 minus 3 is negative 3. If you want to multiply those together and see that they're negative 15, that's fine. But what really matters is a positive times a negative gives me a negative result. Is a negative greater than or equal to 0? It's not. So the middle section has failed to work. Notice that I've marked it in red so that we can keep track that it did not work. Finally, let's check the right-hand side of the picture. We decided we would use x equals 10 to test the right-hand side. When I put 10 in for x, that gives me 10 plus 5 for the first factor, 10 minus 3 for the second factor. Now, 10 plus 5, that's 15, positive 15. 10 minus 3 is 7, a positive 7. If you want to multiply those together, you can, but all that matters is a positive times a positive gives me a positive, and that is greater than or equal to 0 would be true. So the right side of this picture works also. That means when I look at my number line, the left side of the picture worked and the right side of the picture worked, but the middle section fails to work. Now, when we go to express our answer, we're going to want to write this in interval notation. So how I talk about the left-hand side of the picture, it begins at negative infinity and it goes up to negative 5. So the left side of the picture is from negative infinity to negative 5. The right side of the picture starts at 3 and it goes forever this way out to positive infinity. So the right side of the picture is going to be from 3 to infinity. Now let's look at that interval notation. Since we've got greater than or equal to for our inequality, notice that it says greater than or equal to, that means that the critical values will be included. The left-hand side then starts at negative infinity and goes to negative 5. Infinities always get parentheses. The 5, the negative 5, gets a bracket here because of our equals, because it's included. Now, we want to add to that the other section that begins at positive 3 and goes to infinity, parentheses with an infinity and a bracket at the 3 since it's included. And the way that we add those together is with what looks like a U. It stands for the union of the sets. So the way we would express our answer in interval notation is right there, from negative infinity to negative 5, union 3 to infinity. Again, the critical values were included since we had an equal to. Now, let's think about how that would look if we graph the picture on a Cartesian plane in 2 dimensions. Here is my equation. Y is equal to x squared plus 2x minus 15. That was the thing we were working with as our inequality. Now, because of it being a square, a degree of 2, a quadratic equation forms a parabola. The picture is a U shape. Notice that the place that we're crossing the x-axis with our picture, that corresponds to the critical values that we had. Here is negative 5, and here is positive 3. Now, what we wanted to know is, where is our picture more than 0? Where is our picture above the x-axis? The part that it's above the x-axis, right here, we're above the x-axis on the left-hand side of the picture. And then over here, we're above the x-axis on the right-hand side of the picture. The place that we are below the x-axis is between our critical values. So from negative infinity to negative 5, you can find the picture above the x-axis. From 3 to positive infinity for x, you can find the picture above the x-axis. But in between those values, between -5 and 3, the picture is below the x-axis. Let's try another one. This time, let's solve x squared minus 2x minus 3 is strictly less than 0. So this time our critical values are not going to be included since it says strictly less than. Just like we did a minute ago, we want everything on the same side with 0 on the other, and then we want to factor as much as we can. Now, x squared minus 2x minus 3 is going to factor as x minus 3 times x plus 1. So the critical values that we have, from the first factor, we get positive 3. From the second factor, we get -1. -1 is smaller, so let's put it on the left-hand side. Positive 3 is larger. Let's put it on the right-hand side. This divides our number line up into 3 sections. The part less than -1, the part that's between -1 and 3, and then the part that is more than 3. Just like we did before, I need to test each section, picking a number to represent each of the sections. Over here on the left-hand side, I think this time I'll use -5. Notice in the middle, 0 is another choice this time in the middle. So I want to use 0 since that's going to make it as easy as it can be. Then to the right of 3, let's pick something out here like 5 to work with. So now for the left-hand side, we're going to let x be -5. When I substitute into our factored form, -5 goes for each of these x's. Well, -5 minus 3, that's going to give me -8. -5 plus 1, that's going to give me -4. I don't care about the arithmetic there. I care that this was negative and this was negative. When you multiply two negatives, will they be less than 0? No. A negative times a negative makes a positive that's more than 0. So the left-hand side fails to work. Notice that I've marked it in red so that we can remember that it failed to work. The middle section we're going to test with x being 0. So again, in our factored form, let's put 0 in for each of these x's. When I do that, 3 gives me -3, and then 0 plus 1 gives me +1. A negative times a positive is a negative result, and that is less than 0. So the middle section works. I've marked it in green, so we'll remember the middle section works. The right-hand side looks like it's going to fail. If I put 5 in, substituting into our factored form for every x, I'll have 5 minus 3, that's 2, and then I'll have 5 plus 1, that's 6. Both of them are positive. A positive times a positive, that's not less than 0, so it failed to work. The only part that works is the middle section between -1 and 3. This is the part that works. Now, I'm not going to include my critical values. To say that they're not included, let's put parentheses on each side. To say that it is the middle between -1 and 3, we start our interval at -1, we go to 3, close it off on both sides with parentheses because the critical values are not included. Now, how would that look in 2 dimensions? Again, here is how we should do this one in 2 dimensions. First, we have y is equal to x squared minus 2x minus 3 that we're trying to graph. Because of it having a degree of 2, the shape is a parabola. Our critical values of -1 and +3, those are the places we're crossing the x-axis. We were looking this time for where we'll be below the x-axis, where we're going to be less than 0. Look at what your picture does. Where it's below the x-axis is between the x-intercepts of -1 and 3. So in the middle between -1 and 3, that is where we're less than 0. On the edges, our picture is above the x-axis, so our picture is greater than 0 on this side and over here on this side. Between the x-intercepts is where we're less than 0 below the x-axis. To solve a quadratic inequality, get everything on the same side with 0 on the other, factor as much as you can, and find your critical values. Take those critical values and put them on a number line, then check each of the sections that are created with a representative number. The places that are true, that will be the solution that you give in interval notation.